Okay, so this is our first recording, and I kind of messed up, and I think that I maybe cut it off at some point when Levi was trying to explain the difference between RNA and DNA. So, Levi, take it away. What's the difference?
Right, so RNA, ribonucleic acid,
He's so
DNA,
bored.
deoxyribonucleic acid. So, as I was saying before you turned the camera off, they're both basically identical. The difference being a few proteins or amino acids, I should say, that make up DNA and RNA. The difference being DNA is in your cell, it's in your nucleus, and it's what makes every living animal and or plant in the world unique, right? Bananas, tomatoes, bats, people, dogs. They all have the exact same amino acids in their DNA that make up us, right? So most people don't realize that, but the DNA, the code is different, but everybody's made of the exact same thing. Where RNA comes in is...
What do you mean by that, actually? Because that actually surprises me, that we're all made of the same
Yeah. So
stuff?
DNA, deoxyribonucleic acid, DNA. It's I want to say it's four basic amino acids. I'd have to go back and look, but I can't remember. It's U.
Okay.
It doesn't matter anyway. There's four. I want to say there's four. So there are 4 amino acids in the world that make up DNA. There's also a sugar backbone. We won't worry about that. But the code is 4. It's 4 amino acids. Every living thing on the planet Earth has the exact same 4 amino acids. It's the code at which they're run out.
I never knew that.
Yeah, well, now you know.
Yeah.
So that's why when people talk about, like, your DNA is very similar to a banana, that's, I mean, and it actually is, believe it or not. It's because a banana's DNA is made of the same 4 amino acids that your DNA is made of. It's just the code at which. So that's when you see pictures of DNA and they talk about, I think it's TCAU? It's been a while. Anyway, you always see these letters of the alphabet. Those are the first names of the amino acid.
Okay.
Every living thing has those exact same 4. So that's what I meant when I said we're all made of the same things. We are.
Crazy.
But it's the code, and that code is billions and billions and billions. It's like terabytes of information. It's pretty amazing how much is in there.
All right, so back to RNA and DNA.
Backing up. So RNA is, and the example I was using was something I think a lot of people at least somewhat understand is insulin, right? So your body regulates your blood sugar levels, okay? And when your blood sugar levels start to get too high, your body triggers a fact that says, okay, we need insulin. It sends a message through your bloodstream, particular hormone, I don't know the hormone, sends a hormone. That hormone triggers insulin making cells, okay? And what happens is when those cells receive that trigger, there's a very unique spot inside our DNA that says this is how you make insulin. It opens up, it unzips basically, and you start to make RNA. RNA is the message that goes from the nucleus and the DNA to the inside of the cell at the cytoplasm so your cell can start making insulin. And it does that by reading RNA. So RNA essentially is a cookbook on how to make insulin.
That's a good analogy.
So your body, your cells in this case, I'm sorry, not your body, these particular cells will start mass producing insulin. Okay, and all they do is they basically read down the line, and every one of those amino acids is a piece to a protein, and you basically put together a puzzle, and that the end result is, in this case, insulin. So insulin then gets pumped out into your bloodstream, insulin processes the glucose, and poof, your blood sugar levels come back down. Then at that point being is RNA is the messenger, and what viruses are able to do is they hijack the tools inside our cytoplasm and they start replicating themselves because they've injected their own RNA. So they basically take over the cell, and your cell starts mass producing viruses to a point that it busts. And when it busts, now instead of having one virus, you have, thousands of viruses that then spread to other cells. And the whole process starts over again. So that's how viruses spread inside your body.
Wow.
without
so-
your white blood cells to keep them in check.
And so COVID-19 is just another
It's just another,
example.
well, it's a different type of virus.
Right, which is,
Right?
yeah.
So, but at the end of the day, it's still a virus, and it's a virus that is well understood.
And can be contained.
Well,
It
yes,
will
I
be
mean,
containable.
right. So, I mean, we're already watching the news. There's already vaccines in work, right? But you can't just, and it makes sense. I mean, people are frustrated because they're like, oh, well, you know, you should just make a vaccine and go. But I'm like, you can't just start injecting people
I was one of those people.
with viruses because, you know, granted, you know, there's funny movies that have been made with that. But the reality is, you have to be very careful when you start taking virus cultures and injecting them into people. That's really, really dangerous. And there's certain steps you have to keep in place.
Yeah,
So I know people want a vaccine like tomorrow.
right.
And not only that, even if we had a vaccine tomorrow, in order to scale that vaccine up to the billions of people around the world, it's not a light switch. You don't turn it on and all instantly you have power, right? It doesn't work like that. Like you have to, somewhere around the world, you have to have a pharmacy. They have to have a particular setup. You have to grow these batches. You have to, I mean, it's the same way, you know, if you go back to the very origins of gasoline, okay? You didn't just flip a switch and all of a sudden you had 5 billion barrels of gasoline, right? It's the exact same process. You have to have the equipment in place, you have to have the personnel in place, you have to ramp everything up, just like the flu vaccine, and this is where this is gonna go. 1 year from now, you're gonna go to your CVS or your Walgreens, whatever, and when you go to get your flu shot, inside that flu shot will be a COVID-19 vaccine.
Yeah, okay.
Just like the flu.
And so that's where we're going to wrap up, and we will conquer more of those questions at our next thing. So, bye, Layman's Terms with Levi. Thank you.